Okay. All right. So so we're going to continue with the topic that we started last class, and that is small signal analysis. So last class we learned that in order to analyze an amplifier only for small signal, we need to determine the small signal parameters, and the small signal parameters are GM, which is DCIC over VT, and then R pi, which is beta over GM, and then RE equals to alpha over GM. Okay. So today we're going to analyze an common emitter amplifier. And then after the analysis, we're going to determine few parameters. So let's say this is our common emitter amplifier. We have a voltage divider biasing network, and then we have the signal connected to the amplifier through a capacitor C1. And then we take the output from the collector terminal, which is realized across the resistor RL, and that is also connected through a capacitor C2. And we learned why we had to use the capacitor last class. Okay, so we're going to analyze this amplifier only for small signal, only for small signal. And the parameters that we're going to determine after the analysis would be VI, that is the input expression for the input signal at the base terminal, then RIB. So that is the input impedance looking into the base terminal. Okay, so if you look into the base terminal, look into the base terminal, what is the impedance that they were going to? To be precise, it should be here. If you look into the base terminal, what is the equivalent resistance that you're going to see? That's called input impedance. And also RI, the equivalent impedance or equivalent resistance that you're going to see if you look into the amplifier from this side. And then also V naught, the expression for output signal V naught, and then finally the gain, voltage gain, which is V naught over Vi. So these are the parameters that we have to determine. Okay, first thing first. First of all, we need to, if we want to analyze the amplifier only for small signal, we need to determine the small signal parameters GM, R pi, and RE. And notice what is GM. GM is equal to DCIC over VT. So that means if you want to determine GM, R pi, and RE, all you require is to find the value of IC. What is IC? It's a DC IC. All right. So if this is the case, what does that mean? That means I have to analyze the amplifier only for DC signal, only for DC signal. So I need to draw the equivalent circuit. So large signal or DC equivalent, so draw the DC equivalent circuit. First step, draw the DC equivalent circuit. What are the steps to determine to draw the DC equivalent circuit? Number one, you notice we have two capacitors, C1 and C2. And last class, we learned that to a DC signal, capacitors are always open. For VCC, capacitor is always open. C1, C2, both of them are open. So step one, number one, open the capacitor. Right? Okay. So what I'm going to do, copy it and then paste it here. So we have this capacitor, it is open, and this capacitor is open. So the capacitors are all open. Then second step, we apply superposition theorem to remove the AC signal source. So we already know in an amplifier, we have to do with both AC signal and DC signals. Now, if we want to find the effect of DC signal, we have to get rid of the AC signal. So remove the AC or small signal source and apply superposition. We apply superposition theorem. Okay, what should we do? That means we have got uh, this signal source. So they are removed. Now, so notice if you somehow in this circumstance you find that once you have opened the capacitor, it doesn't really matter whether you short it or not. So opening, so doing the step one is more than enough to obtain the DC equivalent circuit. Okay, so now we obtain the DC equivalent circuit. Notice the this part and the right hand part, left hand side and the right hand side of the circuit are disconnected. So we are only left with a voltage divider biasing network, R1, R2, RC, RE, and VCC. So if you analyze this thing, we get DCIC. So let's assume that we have analyzed it. And we have, in fact, we have analyzed it. So beta times VTH minus VBE RTH plus 1 plus beta. Here, VTH, since it's a voltage divider network, and we have already derived this expression, R2, R1 plus R2, VCC, and RTH, R1 parallel R2. Fine. So we are done. So once you have determined IC, you can determine GM, R pi, and RP. GM, R pi, and RP. That's it. So now that we obtain the small signal parameters, the next part would be to draw the AC equivalent circuit. So draw the AC equivalent circuit. Okay. Next is draw AC circuit. Then what are the steps to draw the equivalent circuit? Okay, again, let me draw the so we know that the capacitor. So first of all, steps. Number one, DC sources to be turned off. That means we have DC voltage source, we may have DC current source. They have to be turned off. So how can you turn it off? DC voltage source, sorry, voltage source shorted and current source open. So that is how we turn off DC voltage source and DC current source. Okay, so let's do these things. So first of all, we have got VCC, DC voltage source. If I draw it, so if I short it, what does that mean? Remove it, short it. Step 2, we have capacitors. We already learned last class. The capacitors are considered as short circuit for two AC signal. So capacitors to be shorted. Okay, I have two capacitors. Capacitor 1 and then capacitor 2. So both of them should be shorted. Now, take a moment and look into the circuit. So you will find in the entire amplifier, there is no traces of any DC signal source. No DC signal source, number one. And the capacitors are shorted. So that means that is how the AC signals see the circuit. So that means when you have both DC signal present and AC signal present, so they see the same circuit different way. To the DC signal, it's like a voltage divider biasing as if RS and the AC signal source and RL, they are not part of the circuit. They don't see it. For AC signal, it doesn't see any DC voltage source. All it sees, the capacitors are shorted, capacitors are shorted. Okay. Now you can simplify the circuit. Notice, so let's say this is our base, and that is our collector, and this is our emitter. This is our ground, that is our ground, that is our ground. Now let me draw it. Okay. First of all, so that is our base. Notice from base to ground, we have a resistance R2. Base to ground, we have a resistance R2. Again, from base to another, this one is also ground. Base to ground, we have got another resistance R1. So what does that mean? We have R1 and R2 are connected parallel to each other because they are connected between two nodes. Node 1, node 2. This ground and this ground same point. So you have more than one elements connected between two nodes. They are connected in parallel. So R1 is also connected in parallel. R1 and R2 are connected in parallel. So R1, okay? And then rest of the circuit should be connected as they are. That is our RS. Is the signal source. Okay, so base part is done. Now let's come to the emitter part. Emitter is connected to what? Emitter is connected to the ground through RE. Emitter part is done as well. Then what is the collector part? Notice the collector terminal is connected to RC. And then it goes to the ground. So we can say the collector terminal. And then from collector to collector terminal, we've got a RL resistance, and then it goes to the ground as well. That means RC and RL are connected parallel to each other. Okay, so that is the simplified diagram of this circuit. Same diagram, same circuit, drawn simplified way. Here, that is our, again, this is our VI. This is our VI from here to here. So all VI. That is our V naught. Right? And that is our RIB that we have to determine. Then our put impedance looking into this side. And okay, so, and of course, it is VBE. Now, what we're going to do next? So in order to analyze it, we want to replace the BGT with its model. Okay, so let me draw the model. Okay. First of all, we draw the BGT. So let's draw the hybrid pi model. That is our R pi that we have determined. That is our GM VBE. That is our, okay, and then our emitter terminal, base terminal, collector terminal, and rest of the circuit should be connected as they are. Okay. R2. In the emitter side, and the collector side. So the circuits are simply connected as they are. So that is the same circuit replacing the BGT with this model. All right. Then, okay, so label them as before. So that is our VI, our IB, okay, and that's it.
স্যার এটা হচ্ছে এসি সিগন্যাল মডেল মানে স্মল সিগন্যাল
It's,
মডেল
all of has. From now on, what I'm doing is a small signal model. Only for small signal. You see this circuit, it doesn't have any DC signal source. And then this is a simplified diagram. So any DC signal source. any DC signal source.
স্যার এই
So that
ভিএস
means
স্যার
sorry,
এই যে ভিএসটা
which is signal source, AC signal.
আচ্ছা আচ্ছা ওকে
Don't confuse it as a DC signal. Drawn this way, but it's a AC signal source. Because AC signal source. It's an AC signal source.
স্যার তাহলে আমরা ফার্স্ট ডিসি সার্কিটটা বানাইছিলাম টু ফাইন্ড দি আরপাই এন্ড আরই এভরিথিং এলস, রাইট?
Only first thing we analyze the amplifier only for DC signal to determine IC. Why do we need IC? Because if you can determine IC, we can calculate GM, we can calculate RPI, you can calculate RE. That's what we did the DC equivalent circuit. And once it hasn't been obtained, then we're going to analyze the amplifier only for small signal. So only for small signal. So it means I cannot have any DC signal in it. Suppose that the capacitors are shorted, DC signals are removed. So if you have a DC voltage source, it will be shorted. If there is any DC current source, it will be open. So in our circuit, we don't have any DC current source. So we didn't have to do this operation. And then we simplified it. And then we replaced the BGTU with one of the model. We learned two models, pi model, T model. In that case, we used pi model. You would get the same result if you had used T model. Okay. So the signal source generally always represented by a signal and a resistor in series. That is how the signal source is represented. So that's what it is. So don't confuse that it's a, although it's plus minus, but it in fact, look at the sign. The voltage small letter and subscript is also small letter. It's a signal source, AC signal. Okay. So now, since the signal source, that means the current that will be flowing here is small signal IB, small signal IC, and small signal IE. And the voltage here is small signal VB. Now, we're going to determine, now we are in a position to analyze the entire amplifier only for small signal. So first thing, we have to determine VI. How to determine VI? If I apply KVL from this point up to this point, from here to here. So we get VI, do partial KVL. So I get plus current emitter current is entering, IE RE, so plus minus IE RE plus IE RE plus minus IB RB. Sorry, RB na R pi. Equals to our VI after doing the partial KVL. So that gives us as IB R pi plus I is what? 1 plus beta. Since the BGT is operating in active region, so I can relate IE and IB as IE is equal to 1 plus beta IB. 1 plus beta IB times RE. So if I take IB out, then we get so that is the expression for VI. So one of the things we have determined the expression for VI. Yeah, let's use VI. Okay. Now Now we are going to determine RIB. So in order to determine RIB, let me explain how the
ভিআই
concept-
এর এক্সপ্রেশনটা কিভাবে আসলে আরেকবার দেখাবেন স্যার?
হ্যাঁ, এই যে IB R pi 1 plus beta IB. So if I take IB out, what do we get? R pi plus
না স্যার,
1
মানে
plus
এখানে কি
beta IB.
কেভিএল অ্যাপ্লাই করছেন?
হ্যাঁ, partial কেবল এখান থেকে একটু পর্যন্ত partial কেবল IE plus IE IB R pi equal to VI partial কেবল বুঝে গেছে?
জি স্যার।
Understood? Okay, thanks. Okay, now I'm going to determine the equivalent resistance or the input impedance looking into the base sets. Okay, let me explain the concept of input impedance. Let's say, let's get back to our DC circuit. So let's consider we are in our 101. So let's say we have a circuit like this. Okay, so this is the voltage VI, and I need to determine the current II. So this is our R1, R2, R3, R4. Okay. So how can we do these things? First of all, we can determine the equivalent resistance, R equivalent. So what is the equivalent resistance? So what is the equivalent resistance that you see from here to the right? So we already learned that it is R2 and R3 are parallel. তার সাথে R1 and R4 are connected in series. So I can say, well, R equivalent is in fact R1 plus R4 plus in series. So I can say this R2 and R3 in parallel, তার সাথে R1 and R4 are in series. So I can draw it. Now I can draw the equivalent circuit like this. Okay, can you draw করি? As if the circuit looks like this. All right. So current would be VI and the current is II. So I can determine VII as what? II as VI divided by R equivalent. Or we can also say R equivalent can be written as VI divided by II. So these two circuits are equivalent because after doing this equivalence, this is what? This is what? This is this. Now I have determined the equivalent resistance by doing the normal operation, series and parallel operation. R1 and R4 in series, তার সাথে R2 and R3 parallel and in series. Now I could have done the same. I could determine R eq in this other way as well. From this equation, you notice I is equal to what? Vi is equal to Req. So Req is what? Vi divided by Ii. তার মানে হচ্ছে আমি যদি if I could somehow measure the current II and somehow determine the VI. এই জায়গায়, let's say I can determine VI. So if I divide VI with II, that would give us R equivalent. So there are two ways to determine equivalent circuit. That is the way we use theory, and this is the practical approach. For example, you want to determine the equivalent resistance. You have the circuit. Let's say the circuit constructed on breadboard, and then you want to find out what is the equivalent resistance. In that case, all you have to do is to determine the voltage or measure the voltage between terminal and measure the current that flowing through the terminal, and simply VI divided by II. That's our equivalent resistance. So that's the thing we are going to do. If I want to determine the equivalent resistance, or the resistance that you want to see standing here to right, আমি এখানে দাঁড়িয়ে ডান দিকে তাকালে যে রেজিস্ট্যান্স দেখতে যাচ্ছে, তাহলে আমি কি করতে হবে? Simply I need to determine VI and I need to find the current IB. তাহলে RIB will be what? RIB will be simply VI divided by IB. Isn't that the voltage between the terminal from ground up to the point VI? And what is the current flowing? IB. So the resistance, equivalent resistance would be simply VI divided by RIB according to this logic. So I already find out the expression for VI, which is this. And then you divide it by IB. So IB gets cancelled out. So that gives us RIB equals to R pi plus 1 plus beta I. So that is the resistance. That is the equivalent resistance. So that means what I can do, I can just copy it and paste entire thing to my left. Entire thing to my left. I can, whatever the thing inside the circle, I can replace it with what? A resistance, RIB. Where the current is voltage VI and the current is IB. So that is our RIB. And then if I want to determine RI, that means I want to see how the impedance looks like if I stand here and look to my right. So then I'm going to find what? R1, R2, and RIB are in parallel. So it looks like RI equals to R1 parallel R2 parallel RIB. So it looks like, then again copy it.
Sir,
Just a second. Just a second. আসসালামু আলাইকুম মোসাদ্দেক ভাই। হ্যাঁ, না অসুবিধা নাই। হ্যাঁ। হুম। হুম। হ্যাঁ, আমি বলছিলাম যে ফাংশনাল অ্যানালিসিস করে সো মাল্টিপল সাবসিস্টেম গুলি মাল্টিপল ইয়াতে ইয়ে করা আর কি, প্রত্যেকটা, হ্যাঁ হ্যাঁ, ব্লক যা রিপ্রেজেন্ট করা। তারপর প্রত্যেকটা, হুম বলেন। ওই ওই আমি যেগুলি দেখেছি ওরা বলছে যে প্রত্যেকটা ব্লক কুড বি, সাবসিস্টেম কুড বি obtain multiple ways. আমি আপনার এক্সাম্পলটা দেখালাম, ওই যে আপনার যে ওয়েস্ট ম্যানেজমেন্ট, লেটস সে এটা একটা ব্লক, ওইটা কি বলছে, এটা একটা সেন্সর দিয়ে করতে পারে অথবা ক্যামেরা দিয়ে করতে পারে। সো দ্যাট মেক্স মাল্টিপল ডিজাইন। তো এরকম তাহলে আমি মাল্টিপল কম্বিনেশন ই ক্যান হ্যাভ। এভাবে করে দেখা, মানে দেখাতে হবে কি আমি জানি না, আমাদের প্র্যাকটিসটা একরকম, মানে আমরা বলছি আমি যেই সব ডকুমেন্টস গুলি একটা বই দেখেছি তারা এভাবে জিনিসটা রিপ্রেজেন্ট করেছে। ব্লক মানে আসলে হচ্ছে কি, আপনি যখন একটা একটা সিস্টেমকে যখন আপনি ফাংশনাল অ্যানালিসিস করবেন, block should be somehow the main component should be same, main subsystem should be same, তাই না? ফর এক্সাম্পল আমি মনিটরিং, তারপর অথবা কন্ট্রোল, তারপর অথবা হয়তো এক্সিকিউশন, একটা সিস্টেম যদি ইঞ্জিন একটা সিস্টেম যদি বানাই, এই মনে করি দিস আর দ্য ব্লকস, দিস শুড বি দ্য সেম। আমার যদি স্পেসিফিকেশন ফাংশনাল রিকোয়ারমেন্ট যদি সেম থাকে, দিস শুড বি সামহাউ সেম। দ্যাট ইজ ওয়ে ফাউন্ড আর কি। হুম হুম, হতে পারে, আমি হতে পারে লেটস সে তাদের একটা মনিটরিং আছে, মনিটরিং সিস্টেম আছে, হ্যাঁ লেটস সে তাদের একটা ব্লক আছে, মনিটরিং সিস্টেম ইজ এটা মানে কি সাবসিস্টেম, ফান্ডামেন্টাল ফাংশনাল ব্লক, ফাংশনাল ব্লক মানে ফাংশন, ইট হ্যাজ টু ডু সামথিং, মনিটরিং। এখন তারা যদি মনে করে আই এম গোয়িং টু ডু দ্য মনিটরিং রিমোটলি, দ্যাট কুড বি ওয়ান পসিবিলিটি, অর আই উইল ডু ইট মনিটর রিমোট না করে, মানে আমি ইয়াতে করলাম, সেটাও অ্যানাদার পসিবিলিটি। মানে আমার আন্ডারস্ট্যান্ডিং এ ইট মেক টু টু ডিফারেন্ট ডিজাইন, সেটা হতে পারে। হুম হুম হুম, এটা করতে হবে। মানে আপনি যদি, আমি যদি লাগছে, আমি তো অনেকগুলি কম্বিনেশন পারমিটেশন কম্বিনেশন হয়, অনেকগুলি পসিবল কম্বিনেশন হতে পারে। আমি আমি আমার আমি এটা চিন্তা করছি, যদিও আমরা এভাবে করতেছি না, আমাদের আমি যেটা প্রপোজ করছি সেটা কিন্তু আমাদের প্র্যাকটিসে নাই, আমাদের প্র্যাকটিস কিন্তু এভাবে আমরা করতেছি না। আমি মনে করি এভাবে হয়তো করে, আমাদের প্র্যাকটিসে সামহাউ মানে আসলে খুব ক্লিয়ার না আর কি, যে অ্যাপ্রোচ ডিফারেন্ট হতে হবে। মানে আমাদের যে ব্লক ডায়াগ্রাম গুলো আমরা শো করি, সেগুলো হচ্ছে মোস্টলি ইয়ার উপর থেকে আসে, লেটস সে মাল্টিপল ডিজাইন থেকে আসে। তো আমি যেটা বলতেছিলাম যে আমি যেটা পাইছি সেটা হচ্ছে ব্লক ডায়াগ্রাম, ফাংশনাল ব্লক অ্যানালাইসিস শুরুতে থাকবে, এবং মাল্টিপল ডিজাইনের ক্ষেত্রে তারা দুইটা তিনটা থাকতে পারে, কিন্তু ওইগুলির পারমিটেশন কম্বিনেশন, এখন পারমিটেশন কম্বিনেশন করলে অনেকগুলি আসে, তো এতগুলি তো করার দরকার নাই, আমি কয়েকটা দেখাইতে পারলে তো হলো। আমার তো দরকার হচ্ছে আমাদের মানে এফওয়াইডিপি কি জানি, ওই ইয়ার কি জানি আমাদের আউটকাম বেস এডুকেশনের সাথে মিলানো, তাই না? তো এখন যদি আমার তিনটা ব্লক ডায়াগ্রাম থাকে, আমার তিনটা প্রত্যেকটাতে যদি আমার লেটস সে তিনটা ব্লক ডায়াগ্রাম আছে, তিনটা ফাংশনাল ব্লক আছে, প্রত্যেকটাতে আমার আহ, দুইটা করে আমার ইয়ে আছে, মাল্টিপল ওয়ার, তাহলে আমার 2 × 2 × 2 8 পসিবল কম্বিনেশন হয়ে যায় এখানে। তো আমার তো 8 পসিবল কম্বিনেশন ডিজাইন করার দরকার নাই, তাই না? সেখান থেকে দুই তিনটা একটা দুইটা করলেই হয়। এখন কতটুকু প্র্যাকটিক্যাল করতে গেলে কতটুকু হয় সেটাও একটা ব্যাপার। আমরা যেমন এতক্ষণ বলেছি অ্যাবসলিউটলি ইট হ্যাজ টু বি কমপ্লিটলি, এখন দুইটা কমপ্লিটলি ডিফারেন্ট অ্যাপ্রোচ, এরকম ভাবে না। এটা হয়তো হ্যাঁ, এটা আরো একটু ইয়া করতে হবে, দেখতে হবে। হুম হুম হুম। আচ্ছা আচ্ছা, ঠিক আছে, কোনো অসুবিধা নেই। কল, হ্যাঁ ঠিক আছে, ওকে ওকে, চলো, ওকে। Sorry, everyone, you have been waiting for a while. Okay, so yeah, someone was asking question. Yeah, কেউ একজন কোশ্চেন করছিলেন? কি কোশ্চেন ভুলে গেছেন? Shall we move on?
Yes,
Okay.
sir.
So, okay, so that means now Ri is what? R1 parallel R2 parallel. That means I can replace it like this. So end of the day, what the signal is going to see is this. But to the signal, it is nothing but a internal resistance of the source times the internal impedance of the entire amplifier. So that is our VI. ঠিক আছে? Okay. So next part. So we have determined so far RIB, RI, and VI. We're going to determine V naught. So in order to determine V naught, let's say the current that is flowing here is I naught. And that is our V naught. Then I can write V naught as what? V naught can be written as RC parallel RL, and then the current flowing is I naught. So V naught can be written as V naught can be written as I naught times RC parallel RL, where I naught is in fact IC but in opposite direction because it's the same branch. So that's the same current but in opposite direction. So I can write I naught as minus IC times RC parallel RL, which is minus, and IC is minus GM VBE RC parallel RL. So that is the expression for V naught. So I have got all the expressions. Final expression is what is the gain AV? V naught over VI. So V naught to আমরা জানি minus GM VBE RC parallel RL, and VI is equal to R by 1 plus, sorry, IB times R by plus 1 plus theta RE. Okay. Now notice VBE over IB. That is what? That is in fact R pi. So VBE over IB R pi. Okay. So that means I can write it as this and this can be replaced as R5. That is our ABG. So that is the gain of the, so that how we are going to analyze it. Okay. Any question on that? Any question? Okay. All right. So remember, this topic is really very important. Number one, so we're going to have a quiz, the quiz 3, and next Wednesday. And the topic will be small signal analysis. That means you will be given a circuit like that, and you should be able to draw the DC equivalent circuit, small signal equivalent circuit, and determining GM, RPI, and others, and then find those AV and others. So also, there's a good chance there will be a full question on that topic in the final exam. And most importantly, the design project we're going to post soon, that will be based on those concepts. I'm going to take a class, or I'm going to provide a demonstration as to how we're going to conduct the design in the next class. And another thing, important thing is that I'm going to share a link with you so that you can put your name down to form the group. And the group members should not be more than 3 members. Okay. And all the members must be from the same section. Okay. So now, so next we're going to find out how to, yes. So small signal analysis of MOSFET. So let's determine small signal analysis. MOSFET amplifier. So basic amplification concept remains the same. Okay, let's say this is our amplifier. Okay, so that is our hypothetical amplifier consisting of MOSFET and MOSFET. What do you have? A biasing, BGS, and then VI, the signal that we want to amplify, and then V naught is where we take our output. So that's called common source configuration, right? Okay, again, we have both the DC signal and AC signal present. So the way we're going to represent the same thing is all capital represent large signal, all small represent small signal, and the mixed signal is the instantaneous signal. Okay, so if I say VGS, so VGS, so it's the instantaneous signal because the symbol for the voltage is small, but the subscript is capital. So it represents VGS plus small signal VGS. It's large signal VGS and the small signal VGS. So this is our amplifier. Right? Now, if you want to analyze the amplifier only for large signals, what should we do first? We have to get rid of the AC signal source. So then we have the drain current. We only have the drain current ID. Of course, we are considering the MOSFET is operating in the saturation region because we are considering amplification action. So ID is equal to Kn VGS minus VTN whole square. That's for the MOSFET. Okay, now if the current is, if you have both AC signal present as well as DC signal present, therefore the current that will be flowing will be instantaneous drain current. So that is ID. So what will be the voltage? Instantaneous gate to source voltage. So therefore the ID can be written as Kn VGS minus VTN whole square. Okay, let's do a little bit of math. We expand it. Kn VGS can be written VGS, large signal VGS plus small signal VGS. Minus whole square. Then we do what? Kn VGS minus VTN plus VGS whole square. Okay, if we expand it, then we get Kn VGS minus VTN whole square plus 2 Kn VGS minus VTN times VGS plus Kn VGS square. In that, VGS is small signal. The same is less than 10 millivolt. Well, less than 10 millivolt amplitude. And if I square it, it becomes even more smaller, and that you can get rid of it. Now, this one, what is this? Isn't that the large signal drain current? So this is our drain current, ID. So I can write it as instantaneous drain current as ID, and that one must be what? Small signal ID. So small signal ID. So I can write small signal ID as 2 Kn VGS minus VTN times VGS. Okay, let me do one thing. Let's give me some trouble. Take the entire thing. And open another window. Okay. So ID can be written as 2Kn VGS minus VTN. Okay. Now notice here 2Kn, they are constant. VGS is constant, VTN is constant. So entire thing we assign it to a value, we call it GM. So that is our ID GM VGS. So what I can say, what is GM? GM is in fact ID over VGS equals to 2Kn VGS minus VTN. That can also be expressed this way. So 2 root Kn ID. We're going to use this one. So that means the same GM that we obtained, similar GM for MOSFET. So that's called transconductance. Okay, that is called transconductance. But the good thing about the MOSFET is that unlike BGT has 3 small signal parameters. So they are GM, RPi, and RE. What is MOSFET? There is only one small signal parameter, which is GM, which is two Kn. Again, GM depends on what? GM entirely depends on the large signal ID. So next, the model. So let's say if I want to draw the AC equivalent, small signal equivalent circuit, I'm going to short the DC signal source. So let me draw it. Okay. So that is our VGS, VGS, RD, V naught. Okay, and these are VTT2. So you want to analyze the amplifier only for small signal. আমরা কি জেনেছি? What should I do? Get rid of the DC voltage source. We have two DC voltage here. Okay, I mean, so here the current is, let's say the current is ID. Okay, and it is VGS, and then we get rid of the DC signal source, the DC signal source. Okay, so okay, so what will be the voltage only for small signal, and the current small signal ID. That's a V naught. So V naught. So V naught should be, you'll find out V naught would be minus ID. Now, I can again replace the MOSFET with this small signal model. So find out, so what is the gate current? So it's a gate current. Gate current is always zero. So although that means you between gate and source, there is a voltage VGS, but the current is zero. And between drain and source, ID is equal to what? ID is equal to GM VGS. So that means that the drain and source, I can represent it as a dependent current source, and gate and source, it is an open. So if I replace the MOSFET, it is model, it looks like this. So let's say this is our gate terminal, and this is our source terminal, and this is our drain terminal. So gate. So IG equals to 0, but we have a voltage VGS source, and between drain and source, it's a dependent. So gate, source, and drain. The current is ID, and ID equals to GM VGS. So that's how we can model. So see the difference. When it comes to BJT, base and emitter, we have RPI resistance or RE resistance and dependent current source. Take up. So next we just see one problem. So let's say we have let's solve this problem. Okay, let's say this. We're going to analyze this amplifier, we're going to do the same way we did for BJT. First of all, we're going to determine the small signal parameter. What is the small signal parameter? GM, which is ID, sorry, 2 root KN ID. So that means I need to determine ID. In order to determine ID, what should I do? I have to draw the large signal equivalent circuit. So fortunately, I have these things. That. Okay. Yeah. It's not drawn in a very good way. Okay. Okay, let me draw it again. Okay. Okay. So, and we take our output from here. Not that is our RS, and that is our VI. Okay. So that's the circuit. So first of all, we need to determine the DC equivalent circuit. Draw the DC equivalent. Same step to be followed. Okay. What should I do? VDD. Open the capacitor. That will do. To DC signal, the capacitor is open. Capacitor is open. So then we have only this circuit. If we solve it, we can determine, assume, not assume, we have to take that if the BJT is in fact operating in saturation region. So ID is, we can determine ID as what about the dimensions? Kn VGS minus VTN whole square. Okay, so I have determined ID. Then I know I can determine GM is equal to 2 root Kn ID. Done. So next, I need to draw the S equivalent circuit. So draw the S equivalent circuit. Okay, let me draw it again. Draw S equivalent circuit. Okay, what are the steps? Same step. The DC voltage source to be shorted and capacitor to be shorted. Shorted. So then we're going to simplify it the same way you simplified it before. Okay. Let's say I can use this to simplify. Number one. So you see R1 and R2 be parallel as before, R1 and R2. Parallel. And from the drain, you notice where does it go? It goes to the ground. And R is connected to the ground through RS. That is how the circuit looks like. This is a simplified circuit. Then I'm going to replace the MOSFET model. Okay. Okay. First of all, let's draw the model. Okay, that is a gate, source, and drain. Gate terminal. Okay, what do you have? In the gate terminal, we have R1 and R2 connected in series, parallel, sorry. So we have RS and we have R1 and R2 connected in parallel. তার সাথে আমার plus minus VS RS. So that is our VGS plus minus. And source we have RS resistance connected. And we take output from here. And the drain terminal is connected to the ground. So drain terminal, you see, the drain terminal connected to the ground. Okay, so then as usual, we have to determine those things. So that is how I have to determine VI, V naught, and then the current is ID. Okay, so RI, ঠিক আছে, তাহলে প্রথমে determine করব what is VI. If you apply cable from ground up to that point, so we get VI equals to IDRS plus VGS. What is ID? GM VGS plus VGS. And if I take VGS out, so we get 1 plus GM RS. So that is our VI. And then what is V naught? V naught is equal to simply current is ID flowing, ID RS. And then what is the gain? AV, V naught divided by VI, which is ID RS divided by VGS 1 plus. But ID is equal to আমরা জানি GM VGS RS divided by so VGS cancel out, we get V naught. And then what is the resistance? What is the impedance you're going to find? It is open. So therefore RI should be, RL should be R1 parallel R2. That's it. So you see, it's a very similar technique. Same technique for BGT and same technique for MOSFET. Only thing difference, once up to, you see, once you have replaced the BGT with their model, they're same. They're same. Only thing difference is GM. And for the good thing about the MOSFET is that they don't have any GM. Any question?
So এই নোটটা একটু দিয়ে দিবেন।
Devo, but there's the same thing. I always provide the notes, but the problem is for some reason recently I can't convert this it's a one note. হ্যাঁ, OneNote আমি কেন জানি পিডিএফ এ কনভার্ট করতে পারছি না। আমি যেটা করব, আই এম গোইং টু টেক ইট টু দ্য ইউনিভার্সিটি, মাই ইউনিভার্সিটি পিসি, ফ্রম দ্যার আই উইল একটু ওয়েট করতে হবে, হ্যাঁ। সো ইফ আই ক্যান গো টু দ্য ইউনিভার্সিটি টুমরো, ডেফিনেটলি আই এম গোইং টু শেয়ার ইট টুমরো, আদারওয়াইজ ইউ হ্যাভ টু ওয়েট টিল ইনশাআল্লাহ সানডে।
Okay.
Sir, I heard you are sick. Are you okay?
No, Alhamdulillah, I am okay, but my family members, everyone is sick, chikungunya and the flu. So I have to be at home just to, মানে পাশে সবাই খুবই অসুস্থ, আমি একটু